Hello, this video is on some more characteristics of quadratic functions, and it follows along with some of the information that is in Holt 9.2 of your textbook. So the focus is going to be on finding the zeros of a quadratic function from its graph and equation, and I can find the axis of symmetry and vertex of a parabola. Some of this will be a little bit of review that we've been practicing, some of it will be new. Make sure you take notes as you watch. So the zero of a function is finding the x value that makes the function equal to 0. It's the same thing as the x-intercept of a function, and sometimes it is also referred to as the roots of a function. So it's one of those things that has multiple names. You might hear roots, zeros, or x-intercept. They all are referring to the same thing. Alright, we're going to practice finding some of the zeros. You'll notice we have three different cases here of things that can happen. Our first example here, you can see the vertex is on the x-axis, so this will have exactly one zero. It has one x-intercept. This middle guy here, it actually has two zeros because it crosses twice, so that's our other possibility. And then our third possibility is that there are no zeros or none. And here you can see that's because our parabola is actually above the x-axis and it will never cross. So going back to the one on the left that has 1, 0, for that one the 0 is at x is equal to 1. That's the point where we have an x-intercept. Now the middle one with two zeros, we're going to have two x values to write because it touches the x-axis or crosses it twice. First one is at x is equal to -1 and the second one is at x is 2. And our last one that has no zeros, we don't have anything else to add there because it doesn't ever cross our x-axis. Alright, a couple of things that are review. Excuse me. Axis of symmetry is a vertical line that divides a parabola into two symmetrical halves. So it's where the symmetry happens. If you put a mirror there, that's how we get our reflection. Vertex, we've been talking about for a few days as well. It's the highest or lowest point on a parabola. If you guys remember, vertex is always written as an ordered pair, x, y. So to find the axis of symmetry, couple options. A lot of you guys are visual. You're going to be able to find the axis of symmetry by looking at the graph. And then when we don't have a graph, we'll have another strategy that we can use. So if a function has 1, 0, so it touches the x-axis once, the 0 is the axis of symmetry because it's going to go through the vertex. On the flip side, if a function has two zeros, you're going to use the average of the two zeros. And we're going to use the average because the axis of symmetry will fall between your two zeros, halfway between. Alright, let's look at a couple examples. On the left side, we have 1, 0. Okay, it only touches once. It touches at x is equal to 2. So when there is 1, 0, the axis of symmetry goes right through that vertex, and it's the same thing as the 0 is here. So my axis of symmetry is at x equals 2, and my 0 is also at x equals 2 here. Now the one on the right is a little bit different. This one, when I look at it, I can see it has two zeros. It crosses the x-axis twice. That happens at x is equal to 1 and x is equal to 5. So on the previous slide, what we decided is that to find the axis of symmetry, you're going to take the average of these two numbers. So average is adding them together, dividing by how many there are, so I get 6 over 2, that's 3. That tells me that my axis of symmetry is going to go, so my axis of symmetry, through the number 3. Again, some of you visually are going to be able to tell that, but if you're ever not sure, this is a good strategy. Okay. Now, we don't always work with graphs. Sometimes we are only given an equation. That being said, if you're given an equation, you could graph it to find the axis of symmetry. But if you prefer working with the numbers, we do have a formula that can tell you the axis of symmetry as well. So if we're in standard form, y equals ax squared plus bx plus c, we can simply use this formula, x equals the opposite of b, or negative b, divided by 2a. And that will give us our axis of symmetry. So we're going to look at two examples. I'm going to write out some details here. On our first example, the a value would be 1. There's nothing written there, so it's a 1 in front. And then we need to know our b value for our little formula here. B is 3. All right, so then I'm just going to plug it in. So to find my axis of symmetry, I would do x is the opposite of b, so it's a positive 3. That's going to make it a negative 3 over 2 times a, and a is 1. So if I were to simplify that, I would get x is equal to negative 3 over 2. If you prefer working with decimals, you could change it to negative 1.5 if you would like. All right, let's look at our second example. This one, our a value is negative 2, b is 4. So again, just plug it in, follow along. So x is equal to opposite of b. So negative b is going to turn into negative 4 since it was positive over 2 times a. That gives me negative 4 over negative 4. So in that case, x is equal to 1. That's where my axis of symmetry is. Okay, there's one other thing we have to talk about. The axis of symmetry is really helpful when we are plotting our parabolas, but we're also going to know, or going to want to know, where our vertex falls to give us some more information. So to find the vertex, it's actually just another step past finding the axis of symmetry. So step 1 for finding the vertex, and this is if you don't have a graph. You'd find the x-coordinate of the vertex using the axis of symmetry. Okay, so like we just did in the previous slides, find the AOS. Step 2 says to substitute that x-coordinate that we got from step 1, that axis of symmetry, back into the equation to get the y value and then write it as an ordered pair. So really we're just adding one more step past finding the axis of symmetry. All right, let's look at an example. Our first step was to find the x-coordinate of the vertex. To get the x-coordinate, we are going to find the axis of symmetry. So we have that formula we just were practicing, x equals opposite of b over 2a. Here my a value is negative 1, b is negative 2. So I'm going to plug that in to get started. So I'm going to get x equals opposite of b, so it's going to become positive 2, over 2 times a, negative 1. So I end up with 2 over negative 2. That tells me x is negative 1. That's my axis of symmetry. That's where that symmetry is happening for this specific quadratic function. But for a vertex, I need an ordered pair. So I'm going to take this negative 1 and plug it back into my equation. So I'm going to get y is equal to, now here's where we have to slow down a little bit. There's a negative out front, and then the x is squared. So negative 1 squared minus 2 times negative 1. Order of operations say I'll deal with this exponent first. So I have a negative. Negative 1 squared is positive 1. Negative 2 times negative 1 will turn into plus 2. So I have negative 1 plus 2. Y is equal to 1. So for this problem, my vertex is at negative 1. And remember, I got that from my axis of symmetry. And my y value is positive 1. Final answer. Thanks for watching, guys. After this, you should get together with your partner for this activity and find somewhere to sit with them that, where you guys can work together and then start tackling those practice sheets.